Hello guys, we are continuing with our assignment. We are now going through question 2. And question 2 is still analytical geometry. It contains a lot of, let me say, important mathematical ideas of analytical geometry. The key thing that I will go through it is the right angle triangle, which comes from the idea that tangent is perpendicular to the radius. In this context, I'm going to talk about the right angle triangle, which comes as a result of tangent being perpendicular to the radius. So let's go through it and see what's happening here. They are saying 2.1, M is the center of a circle with the equation x minus 1 squared plus y minus 2 squared equals to 2. So let me talk about this, the equation of this circle, which is x minus 1 squared plus y minus 2 squared equals to 2. This is the equation of this circle that you see here on the diagram. And if you look at the equation of this circle carefully, it can be easily to identify the point of the center of a circle. How? If we take this x minus 1, let me change the color. Let me do this. If we take this x minus 1 here, equate it to 0, and solve for x, our x is 1, and take y minus 2, equate it to 0, and solve for y is 2. So this 1 and 2, they are the coordinates of the center of a circle. So guys, it's very, very important that when we give you the equation of a circle, you are able to identify the coordinates of the center of a circle. In this case, we see that the coordinates of a center of a circle is 1 and 2, which means that the coordinates of M, because M is the center of a circle, it's 1 and 2. Now, from the equation of the center of a circle, we can also be able to identify the radius. Let's go to this equation. Let's go to this equation of the center of a circle, which is x minus 1 squared plus y minus 2 squared equals to 2. So we are going to focus on this number on the right side, which is 2. This number on the right side is not your radius. It's actually your r squared. So you're going to say your r squared is equals to 2. Therefore, r is the square root of 2. So the radius is the square root of 2. So which means the distance from M, which is the center of a circle, to T is the square root of 2. Okay? We have the distance from M to T, which is the radius, which is the square root of 2. I just found it from the equation of a circle. I didn't even have to use the distance formula for trying to find the distance from M to T. No, I just know that M to T is a radius. And from the equation of a circle, the right-hand side value, it's your r squared. So you say r squared equals to 2, and then you find the radius, which is the square root of 2. So the distance from M to T is the square root of 2, which is the radius. Okay, so then another thing that you have to identify on this equation is that this line PT is a tangent line. So we talked about it on our first question, on question 1. Remember, we said tangent is always perpendicular to the radius. So this is tangent. This is the radius, which means that the angle here is 90 degrees. The angle between the tangent and the radius is 90 degrees, which makes this triangle, if I create a line from M to P, makes the triangle MPT the right angle triangle. Okay, now let's go to the question straight away to 2.1.1. They are saying show that PT squared is equals to 2K squared plus 2K plus 3. They want me to find PT. I think they love this problem. I still remember when I was dealing with analytical geometry last year on some previous question papers. They love this kind of a problem. Okay, so hopefully you guys will understand what I'm going to be talking about here. I know the length from M to T is square root of 2. They want me to find the length of PT, or maybe let me say PT being squared. So we are going to find the length of PT and then square that PT. But how are we going to find the distance from P to T? Okay, watch out for the details. I have the radius, I have the distance from M to T. Can I try to find the distance from M to P? Oh, yes. But I will find the distance in terms of K. I'm going to try to find the distance from M to P. I won't try to find the distance from P to T using the distance formula. From P to T using the distance formula just because I don't have the coordinates of T. But I have the coordinates of M, which is 1 and 2. That is the central point. And I have the coordinates of P, which is K and negative K. So I'm going to find the distance of MK. So I'm going to say MK is equals to the square root of, I'm using the distance formula, is the square root of, remember the distance formula, it's x2 minus x1 squared plus y2 minus y1 squared. So this is going to be my x1, my y1. This is going to be my x2, my y2. So I'm going to say mk equals to, oh, it's mp. I'm referring to the distance from M to P. Sorry, it's MP. It's equals to the square root of, how much is my x2? It's K. So I'm going to say K minus my x1, which is 1. K minus 1 squared plus, what is my y2? 2. So I'm going to have 2 minus K, which will become positive K. So 2 plus K squared. So this is the length from M to P in terms of K. Okay. This is the length of MP in terms of K. We can try to manipulate the expression, but for now, I just want to leave it as it is. I want to say the length of MP is the square root of K minus 1 squared plus this plus 2 plus K squared. So I have the length of MP and I have the length of MT, and I will try to find the length of PT. I'm going to use what we call the theorem of Pythagoras to find PT, because the triangle MTP is a right angle triangle. So if you have got a right angle triangle whereby you are given two sides, you can use the theorem of Pythagoras. The theorem of Pythagoras stated that the hypotenuse squared is equals to the opposite squared plus the adjacent squared. I know some of you know the theorem of Pythagoras as r squared equals to y squared plus x squared. No problem. So what is my hypotenuse on this right angle triangle? My hypotenuse is the longest side. So my hypotenuse is going to be MP, I mean, the distance from M to P, because it's the longest side on the right angle triangle MPT. So I'm going to take this longest side, square it. It's my hypotenuse. So I'm going to say uh, r squared, which is, this is my r, mp, it's my r, and I found this mp. So I'm going to say the square root of k minus 1 squared plus 2 plus k squared. What am I saying? 2 plus, let me write neatly. What am I doing? Where am I rushing? Why are you rushing, sir? 2 plus k squared inside, this is mp, and I have to square it. And then say equals to, what is my y? Let me refer to my y as mt, which is square root of 2. I have to square the square root of 2 plus, let my x be pt. So plus pt squared. Okay, so this exponent 2 will surely cancel this square root. So I'll be left with k minus 1 squared plus 2 plus k squared equals to, the square root of 2 squared is 2 plus pt squared. So now let me expand k minus 1 squared. If you expand k minus 1 squared, you're going to have k squared minus 2k plus 1. Then you expand 2 plus k squared. If you expand it, it's going to be 4 plus 4, careful, say 4, yes, plus 4k plus k squared is equals to 2 plus pt squared. As keys, I don't have enough space, guys. Okay, so I'm going to take this 2 to this side. So I'm going to have, let me add also like terms. I'm going to say k squared plus k squared, which is 2k squared. So 2k squared minus 2k plus 4k is 2k. So 2k squared plus 2k. Now I have got 1 plus 4 minus 2, which is 5 minus 2 is going to be 3. We are adding like terms, plus 3, 2k squared plus 2k plus 3 equals to, I'm left with pt squared that side, pt squared. So I did prove that pt squared is equals to 2k squared plus 2k plus 3. Interesting maths. It was not difficult. What you needed there is to know that tangent is perpendicular to the radius. And when tangent is perpendicular to the radius, they form 90 degrees. And because they form 90 degrees, the triangle becomes a right angle triangle. You think of the theorem of Pythagoras. So I'm going to, let me summarize what I've just done here. It was easy to show that pt squared is 2k squared plus 2k plus 3. How so? The first thing that you identify, you say, oh, this is a radius. This is a radius. This is tangent. It means they are perpendicular. This is 90 degrees. Then you can also connect the point, the line from M to P. So you now have a right angle triangle. And you can easily find the distance from M to T, which is your radius. You can get the radius from the equation of a circle. Don't try to find the distance from M to T. From the equation of a circle, you go to the equation of a circle. On the right side of the equation of a circle, you have got these two. Remember, x minus 1 squared plus y minus 2 squared equals to 2. That is the equation of a circle. And on the right side of that equation of circle, that 2 is equals to r squared. You put the square root both sides, r is square root of 2. So you have the distance from m to t is square root of 2. And you can find the distance from m to p using what we call the distance formula. Just because you know the coordinates of m. Remember, m is the center of a circle. The coordinates of the center of the circle, you also take them from the equation of a circle. From the equation of a circle, it's easy to identify the coordinates of a center. This guy here, this one, and this two, these are the coordinates of a center of a circle. So you find 1 and 2. So you use the distance formula to find the distance from M to P. Then because you have you have this side MP and you have this side MT, you use the theorem of Pythagoras to try to find PT. You are actually going to find PT squared. That was a very interesting question from this examiner. I love this assignment. It has got great stuff that teaches very important mathematical ideas that may come anytime in your exam. This is not a joke. What they are doing here, they can bring it anytime in your exam. So we've found 2.1.1. Now let's go to 2.1.2. 2.1.2. Okay. They are saying on 2.1.2, they are saying determine the length of the shortest possible tangent that can be drawn from P to the circle. So they are looking for the shortest possible distance from P to T. That is the distance from, this is the distance of a tangent from P to T. So they are saying, what is the shortest possible distance? Remember, we are having PT. We have PT squared. We know that PT squared equals to 2K squared plus 2K plus 3. So they want to know the shortest length from P to T. Wow. This is interesting question. I wonder if they already taught you calculus, because what they are asking here is the problem of calculus. In the application of calculus, we're actually talking about the application of calculus. If we apply calculus, we can be able to find something at its minimum, and we can also be able to find something at its maximum. It is calculus that helps us to identify the minimum value and also the maximum value. So here, I want to know PT at its minimum. Okay, first thing, let me make PT the subject of the formula. I'm going to say PT is equals to the square root of, I'm putting the square root to both sides, 2K squared plus 2K plus 3. So I want to know this guy PT at its minimum. I want to know the shortest distance, meaning the minimum distance. Remember, PT represents the distance from P to T. So I want to know the minimum distance of PT. What I'm going to do, I apply calculus. I say to find something at its minimum, you need to apply what we call first derivative. I'm going to say the first derivative of PT. So I'm going to say call it PT prime equals to, unfortunately now, differentiating the square root of 2K squared plus 2K plus 3, it is not part of grade 12, because the skill that we need to differentiate here, it is what we call It's a chain rule. There is a rule which we use to differentiate in a higher level of maths. At varsity, when you do first year, you will be differentiating an expression using the rule which is called chain rule. I'll just explain what is a chain rule so that you have an idea of what I'm going to talk about, but I know it's not for grade 12. So let's say you have got something like this. Let's say you have got x plus 2 squared, like this, and you want to differentiate it, okay? I know, guys, what you do when you want to differentiate x plus 2 squared, I know that you do this. You say x plus 2, x plus 2. You firstly put it in a standard form. Now you say it's x squared plus 4x plus 4. You are putting it in a standard form. Then you now derive it. You say 2x plus 4. I believe you are familiar with this. It's ideas of calculus. I know that if you want to differentiate it, you first put it in the standard form, then you differentiate. But in a higher level of maths, we can differentiate it even without putting it in the standard form by making use of what we call chain rule of differentiation. What we do, we say, let us differentiate the whole. So we are going to take, you see this x plus 2 here, being squared, I'm going to see it as a whole expression. So I'm going to take this 2 and write it in the front. So I'm going to say 2, and then I say x plus 2 to the exponent 1. So I'm differentiating x plus 2 squared as the whole expression. So you might not get what I'm talking about because this is not grade 12 stuff. And then I then go and differentiate the inside of the bracket, which is x plus 2. And the inside of the brackets, if you differentiate x plus 2 alone, it's 1. So we see that the derivative, it's actually 2 times x is 2x. 2 times 2, it's 4. So I applied chain rule of differentiation. Okay, so if I differentiate the square root of 2k squared plus 2k plus 3 is going to be something like this. Remember, this 2k squared, let me not rush, 2k squared plus 2k plus 3 in the root can be written as something like this. I can write it as to the exponent 1 over 2. Let me remove this because I've not yet started differentiating. It's still PT. So PT equals to 2k squared plus 2k plus 3 all to the exponent 1 over 2. Now I can differentiate. I can say PT prime equals to, I'm going to differentiate it as a whole. So I'm going to say half, bring a half at the front, and then write 2k squared plus 2k plus 3, and then I go back to the exponent, I subtract 1. My exponent is half, so I subtract 1, it's a negative 1 over 2. Times, now I am differentiating the inside. I was differentiating it as a whole, now I'm differentiating the inside of the bracket. So the derivative of 2k squared, it's 4k plus the derivative of 2k is 2. So it's 4k plus 2. So this is the derivative of PT. Now, for PT to be at its shortest distance, the derivative has to be 0. So I'm going to put PT prime 0. I'm going to say 0 equals to half into 2k squared plus 2k plus 3 to the exponent negative 1 over 2 times 4k plus 2. Now I have got two guys here. I'm going to call this guy A. This whole guy here, I'm going to call it A. and I'm going to call this guy here B, which is, yes, 4k plus 2, it's B. So I'm saying 0 equals to A times B. So for me to multiply two guys, to multiply A and B and get 0, one of this guy has to be 0. A is either going to be 0 or B is going to be 0. One of the two has to be 0. For me to multiply the two guys and get 0, one of them has to be 0. So I'm going to see 4k plus 2, which I said is my B. I said, let me say 4k plus 2, it's 0. One of the two has to be 0. So A is equals to 0 or B equals to 0. So I'm going to focus at B. I'm going to focus at 4k plus 2. So I'm going to say, okay, 4k plus 2 equals to 0. Therefore, 4k equals to negative 2 and k equals to negative 1 over 2. So the length of PT, it's at its mark, it is at its minimum. It is the length of PT is at its shortest, is the shortest distance if the value of k is negative 1 over 2. But I applied some high mathematical concept, varsity level. I applied chain rule. I will tell you exactly what to do as a grade 12 student. Okay, so let me erase and tell you what you were supposed to do. K is equals to, we are saying PT is at its shortest when K is equals to negative 1 over 2. But let me explain what you were supposed to do. Exactly at PT, exactly here where they say PT equals to the square root of 2k squared plus 2k plus 3, you guys say PT is a shortest distance, is a shortest distance if the derivative of the inside of a root, if the derivative of the inside of the root is 0. So PT will be the shortest distance if the derivative of the inside of the root is 0. So I'm going to say, okay, PT prime, but this time around, I'm referring to the derivative of the inside of the root. So I will say PT prime equals to the derivative of 2k squared plus 2k plus 3. The derivative of 2k squared, it's 4k. Remember, I'm assuming that you did calculus. I'm assuming that you know how to derive. But let me just explain this time around. When you derive, you take the exponent, you multiply it with the coefficient of a variable. The number before k is 2. So you say 2 times 2, it's 4. You keep your variable k. You go back to the exponent you subtracted by 1. Your exponent is 2. You subtracted by 1 is going to be 1. So you're going to have 4k to the exponent 1 plus, now you derive 2k. Don't forget, I'm deriving the inside of the root. Now you derive 2k. The derivative of 2k, it's actually 2. You just hide the k. You are left with 2 is 2. And the derivative of 3 is a constant number. The derivative of a constant number is 0. So actually now you say PT prime, I'm saying PT prime, but I'm referring to the inside of a root. It's 4k plus 2. And then now you put it 0. You say 0 equals to 4k plus 2. Negative 4k equals to 2. You solve for k. K is equals to minus 1 over 2. So the length from P to T is the shortest distance if k is negative 1 over 2. So I will go back to the length of PT. and substitute k with -1/2. By so doing, I will find the shortest distance from P to T. So let me do that. Okay, let me erase here. Now I will go back to the formula and say PT is equals to the square root of 2k squared plus 2k plus 3. And then I will say this PT is at its shortest distance if the value of k is -1/2. So I will say -1/2 squared. I'm substituting k with -1/2 because PT is the shortest distance if k is -1/2 plus 3. Therefore, PT equals to, I'm lazy, and I will say, just press your calculator. So for me, I know -1/2 squared, it's 1/4. 1/4 times 2, it's a half. So I have the square root of a half -1 plus 3. For you guys, just press a calculator. So PT equals to the square root of -1 plus 3 is 2. Half plus 2, it's 5/2. So PT is the shortest distance from P to T is the square root of 5/2. This was one of the interesting questions as well. I'm hoping you will understand and grasp the concept. I think 2.1.2 is the one that can be challenging. So let's talk. You can text on my YouTube channel. Let's talk about 2.1.2. Please tell me if it's making sense or not. So let's discuss our mathematical concept. Let us engage so that I can see where I can help. Thank you so much for being with me on question 2. I'm going to stop the meeting.